So an example in the first lesson, okay, in lesson 5, we looked at calculating the pH of weak acids. And in order to do that, we had to use the equilibrium constant Ka. In our data booklets on page 8 and 9, right here is a column, right there, is a column of all the Ka values for various weak acids. Okay. Now, there we go. Okay, right here. No, right there. Okay. Now, what happens when we're dealing with weak bases? Okay. When we're dealing with weak bases, we don't have that simple table. We have to do an extra step. Okay. However, last year we learned what Kw was. Kw was the equilibrium constant for water's autoionization, okay, which last year we said was equal to the concentration of hydronium times the concentration of OH minus. Still true. This year we're learning something new, which is basically saying the same thing. It's Ka times Kb. So this was Chem 20, and this is now Chem 30. They mean the same thing, okay? Now Kw is 1.00 times 10. My blue marker is fading. I gotta get some new markers, okay? So Kw is 1.00 times 10 to the negative 14, all right? And that's equal to Ka times Kb. Now, if I'm solving for Kb, then I have to divide both sides by Ka. And this is the formula that I'm going to use. Now, the question, example 2, says, what is Kb for the hypochlorite ion? Okay, the hypochlorite ion is OCl minus. That's hypochlorite. So what I need to do is I need to get my data booklet, and I need to look for where OCl minus is. Okay, now OCl minus doesn't have an H, so it's not going to be in my acids column. It's going to be in my bases column. So I'm scrolling, and I see it. I see it as a base, okay? And the acid is HOCl. So that reaction, guys, is going to look like this. HOCl, based on this information, HOCl plus H2O, okay, equilibrium, OCl minus, and H3O plus. That is the reaction that is in my data booklet right here. Oh, you guys can see that. So small. Let me show it. Okay, right. Where's the marker? Right there. That's the acid. That's the base. And that, my friends, has a Ka value of 4.0 times 10 to the negative 8 for this acid reaction. Now, I don't care about the acid reaction, okay? This tells me what this is like as an acid. I don't care about that. I want Kb. Kb tells me what this, which is what I care about, the hypochlorite ion, is like as a base. So Kb is 1.00 times 10 to the negative 14 divided by Ka, 4.0 times 10 to the negative 8. So Kb is equal to, again, use brackets, 1.00 exponent minus 14. Okay, use brackets, don't get lazy. Divided by 4.0 exponent minus 8. And I'm going to get 2.5 times 10 to the negative 7. Okay, that's my answer. Now, if I was like, use this information to determine concentration of OH minus, you would have to write the basic reaction. Again, this is the acid reaction, but I don't care about that. I care about the base. So to write the base reaction, which is what we're worrying about in this lesson, you take OCl minus, which is a base, you react it with water. It's in equilibrium because it's weak, because Kb is very small. It's going to steal a hydrogen, okay, to give us OH minus and HOCl. And Kb for this basic reaction we just calculated is 2.5 times 10 to the negative 7. Okay, so again, we have to use the acid reaction, the acid equilibrium, to help us figure out the base equilibrium, which is shown by Kb. Okay, it's a little tricky, but the more you do it, the more you'll get used to it. And we're going to see how this works more in the next example.